Welcome. Today we're going to take a look at how we can answer some complex queries in SQL using the power of a named query. To solve some of these problems, we're going to use a named query to take care of some of that problem. Because a lot of times when we're building some of these really complex queries to answer questions about a database, you might notice that we're using the same information over and over again. And normally when we're talking about programming, like, oh, I can make a variable and reference that throughout that. But when we're talking database, it's a little bit different. We don't have that ease of option to make sure I can go ahead and do that. So instead, I could just rewrite that same query over and over again. I write it as an outer query and write that same query again, maybe with an extra column of data of information, get an extra column for that inside as a subquery inside that, and then another subquery, that same piece of information there. But we have no time for that nonsense. We need to get rid of that. And so just like Sherry Collins here is saying, like, yeah, don't even do that. Instead, what we're going to do is we're going to name a query and reference that throughout an entire query, including subqueries. Because previously, if we're working with something like an inline view, I only have it on that outer edge of the actual query I can work with. I can't take it inside and go deeper with it. But with a named query, I can take that as arbitrarily deep inside my query as I want to, and I can really do some cool stuff with that. So let's go ahead and take a look and see how we can make that happen. So you can see the syntax for a named query right here. So we have with our named query as, and then we use our vertically aligned set of parens, and then we have our full-on query inside there. And because the named query is a full actual query, we can even use the order by clause and row num and all that cool stuff to limit our results and do some really cool stuff to sort that information if we need to. Do a lot of cool stuff with that. Then we have our full-on regular select from ... and closing their semicolon. We can use that named query inside a from clause. We can use it inside a where clause, another subquery. We can use this as arbitrarily deep as we want to, but the structure is, so I have my with, my named query as, my parens, and I have my query inside that, and then I can reference it anywhere inside my rest of the query as I need to. So let's go ahead and take a look at a question we can do to solve this and how we can actually work with using a named query to solve that problem. So here's our question. We want to find all the students who live in cities with less than the average number of enrolled students. So that gives us a bunch of information we're looking with when we're talking about the student database to find that information. So to calculate that information, we're going to break that problem down and see what we can do to actually solve that. So let's go ahead and do that. So the first thing we have is we have our named query. This is the first part we want to take a look at and solve. This is the information we use in more than one spot. And so we need to count the number of students who are enrolled by the city. And this requires joining from student to enrollment, and then joining to zip to get the appropriate count by city because the city is stored inside that zip table. And then we're going to go ahead and correlate it exists subquery so we can only add the students who are enrolled. So we've got a subquery inside that. So we're practicing using subqueries all throughout this anyway. So we've got that named query up at the top. Then we're going to need to subquery. It's going to retrieve the cities from that stored query, and only if they have less than the average numbers of students per city. Again, using another subquery on that existing data set. Then in our outer query, our main query we're working with, we want to get those distinct students by joining the student, the enrollment, and zip code tables again, and limiting the results based on those subqueries results that match that named query we just specified up above. So let's go ahead and take a look at the complex code that we use to solve that, and we can actually see how to make that happen. So here we have the solution for that in SQL. So we have our name query up here at the top, and so we have with count by city as, and then I have select my count star as number enrolled, and then zip.city. And this is actually the key for this table. It's one of the things you really want to notice is the fact that when you're creating this table, you can create your own key for it. In this case, it's the city we're working with. From zip code zip, join student stu, on zip.zip is stu.zip. Okay, standard FKPK join. And then joining enrollment enter on student ID is equal to enter.student ID. Okay, easy peasy. And then we're going to do the where exists, and we have our subquery again. And this is again a correlated subquery. So we're going to select X from student, where the student ID matching students table matches the outer table's enr.student ID. So I only add a row if and only if there's a corresponding row on that inner query. And we're going to group this by zip.city, so that's going to give us the results we need to actually grab all the city counts and the associated students with that. And then we have our base query. And so in our base query, we're going to select the distinct student IDs from student stu, joining enrollment en. And then we're going to go on student ID is equal to en.student ID. And then we have zip code zip, and we're going zip.zip is equal to stu.zip, standard query join right there as well. And then we're zip.city is in, and then we're going to select cbc.city from count by city cbc. So that's referencing that outer query, or that named query up above. And then we're going to do that where the cbc.number enrolled, the outer column that we're looking with, is less than, and then we're going to select average from count by city from number enrolled from count by city. So we're going to do a subquery on that, calculating the average value of that, and grabbing that information from there so I can reference it yet again. And then I'm going to order that by the student IDs descending. So I can go through and I can grab that information. So by using the idea of this named query with this stuff over here on the left, I can generate all the table information I need that I can use for any part of my query on the right, because I can arbitrarily nest it as deep as I need to solve that problem. And so this is a helpful way you can take and solve a larger problem by first extracting all the data you need into its own named query, put it at the top of your query you're working with, and then you can reference that all the way through your table on the right and go down through your entire project. I hope this is a helpful way to understand how you can do a named query query to solve large complex problems so you don't have to rewrite the same query over and over again inside your subqueries. And it's a great way you can make your problem even better. Hope this is helpful. Cheers. We'll see you next time. Have a great day. Bye-bye.